Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
We are
the
Team
Pink
Cement. What is cement? Cement is the most important part of building materials. Cement concrete is most widely used non-metallic materials in construction of buildings, dams, bridges, highways, and etc. The first engineering structure made of cement was Thames River Tunnel in 1828. Cement is a dirty greenish heavy powder. It can be described as material possessing adhesive and cohesive properties and capable of bonding materials like stones, bricks, building blocks, and etc. Cement has a property of setting and hardening in the presence of water, so it is called as hydraulic cement. There are 4 types of cement classified based on their chemical composition. These are natural cement, pozzolana cement, slag cement, and Portland cement. In our topic, we will focusing on Portland cement since this is the most widely used non-metallic in construction.
Portland cement is the basic ingredients of concrete. Concrete is formed when Portland cement creates a paste with water that binds with sand and rock to harden. The use of cement goes back many thousand years. The first occurrence of Portland came about in the 19th century. In 1824, Joseph Ashdin, a Leeds mason, took out a patent on hydraulic cement that he coined Portland cement. By the way, hydraulic cement is an inorganic material or a mixture of inorganic materials that sets and develops strength by chemical reaction with water by formation of hydrates and is capable of doing underwater. Composition of Portland cement. A good sample of Portland cement are the following. Calcium oxide that from limestone, chalks, shell, or calcareous rock is about to 60 to 70%. Silica from sand, old bottles, clay, or argillaceous rock is about 20 to 24%. Alumina from bauxite, recycled aluminum is about 5 to 7.5%. Magnesia that found in large deposit in minerals such as magnesite and dolomite is about 2 to 3%. Ferric oxide 1 to 2.5%. Sulfur trioxide 1 to 1.5%. Sulfur oxide 1%. Potassium oxide 1%.
Setting and hardening of cement. Cement, when mixed with the water, form a plastic mass called cement paste. During hydration reaction, gel and crystalline product are formed. The interlocking of the crystal binds the inert particles of the aggregates into the compact rock-like materials. This process of solidification comprises of setting and then hardening. Setting is defined as stiffening of the original plastic mass due to initial gel formation. Hardening is the development of strength due to crystallization. Setting and hardening result from the continuing reaction between the cementitious materials and water. Due to the gradual process of the crystallization in the interior mass of cement, hardening starts after setting. The strength developed by cement paste at any time depends upon the amount of gel formed and the extent of crystallization. The setting and hardening of cement is due to the formation of interlocking crystal reinforced by rigid gels formed by the hydration and hydrolysis of the constitutional compound.
I'm going to report the reactions involved in setting and hardening of cement. When cement is mixed with water, the paste becomes rigid within a short of time, which is known as initial setting. This is due to the hydration of tricalcium aluminate and gel formation of tetracalcium. The calcium silicate also hydrolyzes to Vermilite gel, which contribute to initial setting. Next is the final setting and hardening of cement base is due to the formation of Vermilite gel and crystallization of calcium hydroxide and hydrated tricalcium aluminate. So first, what is Vermilite gel? Vermilite occurs in hydrated cement base and can be found in nature as alteration mineral in metamorphosed limestone and in skarn. What is Vermilite gel do in cement? The calcium silicate hydrate, Vermilite gel, plays a vital role in determining the rheological properties of fresh Portland cement paste and workability of fresh concrete. It determines the setting and hardening rates of the paste and the strength and the dimensional stability of the concrete. What does calcium hydroxide do in cement? Calcium hydroxide cements are used for lining specific areas of deep cavities or for direct pulp capping. The antibacterial action of calcium hydroxide makes this cement useful in indirect pulp capping procedures involving carious denting. What is the tricalcium aluminate? Tricalcium aluminate is the most reactive component of the Portland cement, and its hydration has an important impact on the workability and early strength of concrete. Next is, what is the role of tricalcium aluminate in cement? Tricalcium aluminate is known to have the fastest hydration rate among the main components of Portland cement. The addition of tricalcium aluminate to tricalcium silicate accelerated the hydration process, reduced the setting time, and improve the compressive strength.
The time at which cement completely loses its plasticity and become hard in the final setting time of cement. The time taken by cement to gain its entire strength is the final setting time of cement. For ordinary Portland cement, the final setting time is 600 minutes or 10 hours.
Are the team Pink Cement?
We are the pink cement.
Are the team Pink Cement?
Is the pink cement.
We are the pink cement.